In this video, we will be talking about the coplanar waveguide and introducing an Antenova program to simplify and speed the designing process for our antennas. The simple reason for a transmission line is to transfer RF energy from one place to another with minimal loss. With devices becoming more complex, PCB designers don't want to consume too much time on a single RF trace when they have the whole board to complete. But at the same time, the last problem you need is a device with poor RF performance because of that single RF trace. For embedded antennas, the most suitable antenna feed is to use a grounded coplanar waveguide. This is constructed using a ground plane under the feed and adjacent grounds either side of the feed. For a GCPW or ground coplanar waveguide, the dimensions have to be calculated correctly for the PCB stack-up used. So the main defining feature to use when deciding the antenna feed is the height between the component layer and the ground plane below. You also need to take into account other aspects such as matching component size. The transmission line width should be suitable for the component sizes you are planning to use for the antenna matching circuit. Space-saving design. PCBAs are more and more compact with more components squeezed onto them. The last thing you need is a large trace to take any greatly needed space away. So with these considerations when designing a transmission line, it would be useful to have a simple, easy-to-use calculator which considers these aspects all for you. This is where Antenova Transmission Line tool comes in useful. Let's take a look at an overview of the program. The operation is simple and needs minimal explanation. Select the Antenova product you will be using from the drop-down menu. Input the dielectric constant for the FR4 used. Input the height between your component side and ground plane. This can be in millimeters or mil. That's all there is to it. You will now have a transmission line calculated suitable for the antenna you are using and for whichever component size you use. There is also an interactive graph that shows options for you to select the perfect dimensions for your PCB. Simply move your cursor over the graph to dynamically show the calculated impedance at any given combination of the width versus the gap. All that is left for you to do is to select the option suited for your PCB and continue with your layout. Thank you for watching.